So in this question, we've been given the mean and the standard deviation of the test marks of 40 pupils in a maths class. And those values are 65 and 18 respectively. So the mean is 65 and the standard deviation is 18. The mean and standard deviation of the test marks of the 24 boys of the class are 72 and 20 respectively. And we've been asked to find the mean and standard deviation of the test mark of the 16 girls in the class. So for this class, we have two statistics, namely the mean and the standard deviation. We have it for the entire class, and we have those values for the boys. We've been asked to find those values for the girls. So I'm going to start with a table and use that to represent the groups, so the boys and the girls, and then everybody, and the individual summary statistics we can have. The sum of x, the frequency, the sample size, which is n, x bar for the mean, the sum of x squared, and sigma for the standard deviation. So, reading through the question again, I should be able to substitute some of these values in. First, we know that there's 40 pupils altogether, so n for everybody is 40, and we know the mean, the x bar value, 65, and the standard deviation, 18. So all of this is in that first sentence of the question. We also know that there's 24 boys, their mean is 72, and their standard deviation is 20. And the last bit of information that we were given is that there's 16 girls in the class. Okay, so in blue is all the information from the question. We can deduce a lot from here. So we have a look at the formula for x bar. It's sum of x divided by n. Now that can be rearranged, and I can find the sum of x by multiplying x bar by n. We should be able to find the sum of x by using x bar multiplied by n. We can do that for both the boys and for everybody. Now, since we know the sum of everybody's score, and we know the sum of the boys' scores, we should be able to find the sum of the girls' scores. Just by subtracting, we'll get 872, and now we can find the mean score for the girls. We should be able to do something similar for the standard deviation. Let's look at the formula. So, standard deviation, sigma, equals the square root of the sum of x squared over n minus the sum of x over n squared. The only piece of information we don't know here is the sum of x squared. So we can rearrange and try to make that the subject. So we can square both sides, we can add on the mean squared, and then we can multiply by n. And that will leave us with sum of x squared as the subject. If we substitute into this, we can find the sum of x squared for the boys, and we can find the sum of x squared for everybody. Let's start with everybody. So we know the n value is going to be 40. We're going to multiply that by sigma squared, 18 squared, plus x bar squared, 65 squared, and just type that into the calculator. That gives us a sum of x squared, 181,960. We can do the same thing for the boys. I think I need to fix this labeling here. So that was everybody, that first line. This is for the boys. The n value is 20, sigma is 20, x bar is 72. Once again, into the calculator. A sense check, I'm expecting a smaller number. It should definitely be smaller. The sum of x squared for just the boys versus the sum of x squared for everybody. 134,016. Okay, just like before, we should be able to do a subtraction to get the sum of x squared for the girls. Once we have that, we have everything we need to find the standard deviation. So here we know that sigma is going to equal the original formula, the sum of x squared over n minus the sum of x over n all squared. So just substitute all of that in and then into our calculator. This is the sort of question that really tests that you understand the formula that we're using, that you have the basic algebraic skills of rearranging, substituting, and evaluating. So Yes, your calculator can find the mean and the standard deviation for you. It does not mean the examiner isn't going to test your understanding of the formula and your algebraic ability.